Welcome again, everyone. Those of you who haven't welcomed already. This morning,
Welcome.
yes. This morning we're going to be. We'll have both Georgi and myself doing a presentation. Georgi is in Warsaw, in Poland, with his partner there, Ala. And it's 11 p.m. at night where he is, so I know there's some other Europeans here. I just wanted to run through what we're going to run through today. If you can just go to the second slide there, Guru. So we're going to be talking today about Keyline geographic elements, Keyline geographic analysis. So Georgi will be doing most of that, and then I will do a discussion on land elements, land classes, and land capability. So there should be quite a lot of questions, I imagine, today, and quite a few that are still to come. And with that, I think I'll hand over to you, mate, so we can get the ball running.
Thank you. Hello, everyone, and welcome. Today we will be talking, or at least I will be talking, about Keyline geographic analysis, what that is, and what it means, and how you can approach it. So first off, to start, let's just define what it means, what geographic analysis means in Keyline. So Keyline geographic analysis is the process of subdividing the landscape into its primary land units as they are defined in Keyline. And we'll talk about what exactly that definition is in just a moment. I just want to talk about first why we do this to begin with. The main reason is that the problem of design is that you have too much choice. If you start with a blank canvas, or even if you don't, to move towards a regenerative structure in design, you just have too many options to deal with, too many unexplored scenarios. You don't know where to start, and you get into a place where there's just too much choice pollution that causes confusion. So that is why in the first 2 weeks of this course, and also in the Regradients program, holistic context is at the very top of the list. It's where you start, because the holistic context is the principal filtering medium of choice. Like everything in the platform is basically based on your holistic context. It's always referring back to it, and everything is filtered through it. But once you move onto actual land design, then you're still going to use the context, but you need to start using a framework and a process to kind of subdivide the land into small manageable chunks that you then tackle each one at a time. So the artistry and the heart of design is in finding ways to narrow options down until you get to just those few realistic ones that work within your context and for your land. So Keyline geographic analysis is just one of the many tools to use to get to that place where you just one of the many tools that helps you get there. So to begin the conversation about this, it's good to start with defining some terminology and then go through the actual breakdown of a landscape according to Keyline analysis. So in the original books on Keyline that Yeomans wrote, he defined the different land shapes according to his own terminology, because you have to take into account that Keyline was and is the first design platform of its kind in human history. So it makes sense that a new terminology had to be invented, and that's why it can be so confusing to read. And during this presentation and some of the works I'm investing my time in, I trying to facilitate understanding through graphics and 3D graphics and other means that just weren't available at the time. So that's why the books are lacking in these kind of tools to facilitate some understanding. So when you look at the landscape, there are two main shapes, to say, like there are ridges and there are valleys. Like literally, it's protrusions and depressions in the landscape. So these are the two main shapes we have to deal with, and they have a various hierarchy in any particular landscape. So in Keyline, ridges are broken down into three main types. The first one is called a main ridge. So this is, if you look at the horizon line, is the highest ridge line on the horizon, and it is the water divide line that divides the different catchments. It's the primary water divide line. Along the length of a main ridge, there are crests, which are basically just protrusions that rise along that center line, and they always have a descending relationship as they go along the length of a main ridge, and they are separated by saddle formations. Then the third types of ridge lines are called primary ridges, which follow down the slope stemming off of a main ridge until they reach a secondary valley, a creek, or a floodplain. Then there are valleys, which are the deposition places or areas in a landscape. And there again, mainly three types. There are saddles, which we just mentioned. They are positioned along the center line of the main ridge, and they are the very first deposition landforms in the landscape. You always find them between crests, and they also follow the same falling and rising relationship that is dictated by the main ridge. Then there are primary valleys, which if you have saddles, they always follow off of a saddle down the slope. So they're, if not, then they always follow again off of a main ridge, and they're found in between two primary ridges. The primary valleys, they usually drain. They can drain into a secondary valley, or they can drain into a creek. And I will talk about that in just a bit. Then you have secondary valleys. People usually call these creeks. They're not necessarily creeks, at least not in Keyline. Secondary valley is just is formed by the joining of the water flows of two or more primary valleys, whereas a creek is formed by the flow of two or more secondary valleys. That is the one of the main differences. So this is one of the images that originally is found in, I think it's in the City Forest book by Yeomans. I just converted it into 3D to help understand some of these of these terms. So you can see at the 280th contour at the very top is the main ridge, and this particular illustration does not have any shadows or crests, but I will show you some other ones that are illustrating this point better. So very top is the main ridge, and that follows down the slope. The primary ridges, they stop as they reach the floodplain or the creek or the secondary valley. On either side of a primary ridge is a primary valley, which again follows down from the main ridge and stops at the floodplain or the creek. And we will talk a little bit, we'll go back to this illustration in a moment when we talk about key points and key lines. So I think you can see that it's a very simple concept. I mean, any person understands valleys and ridges. It's just the terminology can sometimes get in the way. But I hope the illustrations help. Now, in terms of key points and key lines, we should go back to the original way that humans describe this, and they as belonging to the valley, because there's been some misinformation going around that key lines somehow extends beyond the valley, and this is simply not true. It just doesn't happen. Well, I'll just explain in a moment. Now, a key point of the valley is always found either in a saddle or in a primary valley. Now, every saddle and every primary valley will always have a key point. And they, in saddles, are located in the apex of each saddle, whereas in the primary valley, they are located along the center line of the valley, just right below the point of inflection where the landscape starts to flatten. Key lines, on the other hand, they are again belonging, or rather stemming off of a key point, so they are always found again in a saddle or in a primary valley. In saddles, they just are a topographic contour line that extends from the key point in the saddle and extends just towards the adjacent crests on both sides, ending at the very edge of the saddle formation. So the key line does never extend beyond that edge on the actual crest. Similarly, in the primary valley, the key line is just a contour line that extends from the key point on both sides towards the adjacent primary ridges and ends at the very edge of the valley. So it does not extend onto the actual primary ridge. And I'll go back to the illustration just to show you this. Just give me a moment. So as you see here, this primary valley has a key point right at the point where the landscape starts to flatten. So the contours are very steep right above it, and then they start to flatten below it. And a key line would extend from that point towards the primary ridges on either side, and it ends at this point where the formation starts to become a ridge. So a key line always belongs to the domain of a valley and never extends beyond it. Similarly, in saddles, the same thing happens. It's just in a saddle type of formation. Here is another illustration. All of these illustrations are free online. I have uploaded them, and if you just search for them in Google, you will find them. I will also put them into the week 5 folder. Another thing to bear in mind is that all key points and key lines have the same falling and rising relationship as the rest of the landscape elements. It's just if you look at the mountain range of any landscape, you see a falling and rising happening, because a mountain is not a straight line. It has falling and rising happening along its length. So similarly, if we go back to the illustration, a key point here will be at a different elevation from a key point in the next primary valley or the one before it. So bear in mind this, because as I mentioned, there has been some misinformation going on that you can somehow extend a key line from one valley to another and it will meet another key point, and so on. This just doesn't happen. It has no logic in it. Now, another thing is that Keyline, Yeomans defined landscapes by distance in a way. So he divided into three types of landscapes. The first one is a long landscape where the distance between a main ridge and a secondary valley, creek, or a stream exceeds 2 kilometers. A medium landscape where the distance is between 1 and 2 kilometers, and a short landscape where the distance is between 500 meters or 1 kilometer. Darren can probably say more about why he did this. I personally find that there's some relationship between this distance and how it affects some of the actual land formations, but this is a deeper discussion that we can take into Slack to just dive deeper into it if somebody is interested. Just bear in mind for now that there's this kind of subdivision. The actual definition of a primary land unit is a catchment area defined by the water divide line between the crests and main ridge. The water divide line is located on two opposite primary ridges and the creek below. So each primary land unit should always have a primary valley, key point, and key line. So just to go back to the illustration, a primary land unit in this case would be this area. So the main ridge above will act as a boundary on the top. A primary ridge on one side will act as the boundary. The primary ridge on the other side will act as a boundary, and the creek secondary valley or the floodplain below will act as the bottom boundary. So this area is defined as a primary land unit. And similarly, on the other side, you have another primary land unit defined by these elements. Now, once you start doing this on the whole landscape, you get a very clear subdivision that divides your land into small manageable chunks that you can start tackling in a particular way. So I just want to show you this, to talk about some of this in a more more intuitive way. I have this. We took a topographic survey of one of the properties that of the first property that Yeomans bought in the 1930s, I think. This is Georgi. So we took the original survey that was made for this and we converted it to 3D. I want to just go through all of the landscape elements and see how this property was subdivided originally. Now, when you look at it, there is a very clear main ridge running all throughout the very top. And from that stem primary ridges down to the secondary valleys, and also you have primary valleys in between that, again going down to a secondary valley, and then you have the actual secondary valleys in between. So this is pretty much it. It works on every kind of landscape because they all have the same features. Now, in terms of primary land units, then they're easy to find once you do this subdivision. Here is one, another one, and so on. Now, in terms of key points and key lines, this landscape has quite a lot of them. We did a study on this, but basically every primary valley or saddle will have one. So one may be here, another may be somewhere here, and so on. Now, in terms of saddles, as we talked about, this landscape has a saddle over here. There's another saddle over here. So just in between these kind of crests. And each of these saddles will have a key point. Just reading a question. Yes, Darren mentions that primary land unit could also be called the first catchment. Okay. Now, in terms of outlining doing this analysis and actually outlining these lines to begin the subdivision, there are two basic ways to do it. One is manually to go out and outline them based on a topographic survey using software like Google Earth, QGIS, ArcGIS, Map 3D, Civil 3D, AutoCAD, and others. Or you can do it semi-automatically by using GIS analysis, where you can have the software figure out a lot of it for you. Where this is usually useful is when you have really complex landscapes, because it's not always so clear what is a primary ridge, what is a primary valley. Like there were questions in forums by some people who had problems figuring out what is actually, is this a primary valley or is it a false valley, and is this a primary ridge, and so on. Now, in instances like these, and when we work on big projects where efficiency is important also, sometimes I just let the computer figure it out for me based on criteria. Like, for example, I can say, based on how much catchment this valley has, it is either a true valley, or I mean, it's either a primary or secondary valley, or it's a false valley. And similarly, based on how much catchment this primary land unit has, these ridges define the watershed, or they don't. So they then are either primary ridges or a main ridge, or they're not. And I would just want to show you first the GIS approach, just to highlight when it's appropriate, and that it's not always so clear when we're talking about these divisions. So I have here one project where a LiDAR survey was made for this landscape, and the original survey, so when the plane flew over, it captured two types of data. The first one was where the unit captured everything that exists on the land, so all of the surface information. And this landscape has a lot of trees, like most of it was forested. During the processing, the trees were removed, so all of the surface features were taken away, and just the actual terrain model was left, so just the bare earth. And this is what I'm using for the analysis, because it just makes no sense to use a survey that has all these surface features that affect the hydrological analysis or the geographic analysis and so on. In some instances, like if you're doing urban design, it makes sense to use them, because that's what defines the watershed, the buildings and the pavement and all of these things. But in terms of these land-based projects, I've never found the instance where I have to use the surface features. So you usually go always for a DTM, a digital terrain model. Sometimes that means both of these type of surveys, both the digital surface and a digital bare earth model. Most of the time is used interchangeably for a model where you have just the bare earth. So this UTTM serves as the very basis of my analysis. Afterwards, I extract a simple hue shade image out of it, just to get some definition. And you can clearly see some of the valleys and the ridges are defined and help you understand what's going on. After that, I do a slope analysis. Now, I usually do a few types of slope analysis. One that is a general one, and you can see the degree values outlined here. So it will outline everywhere where I have 0 to 1, 1 to 2, 8 to 10 degrees, and so on, and visually portray them for me. Now, if I do a few types of those, I usually do varying degrees of detail. So I might do another one where I just want to target slopes that are from 0.1 degree to 1 degree, for example. It all depends on the project you're working on. As you can see, this landscape is very steep for the most part, but if you look at the 0 to 3 to 5 degree areas, you can see a valley here is very clearly defined as a flattened, like an area where the slopes flatten. So that most clearly is either a key point or somebody has gone in and intervened here. In these other valleys, it's not so apparent, although you might be able to see some flattening occurring. Now, if I do a more detailed analysis of the slopes, I might be able to get a clearer definition of what's going on in these valleys. So I usually do that sometimes. Next, I will extract a contour map, which is standard. This one is 1 meter. I can go down to 25 centimeters for this survey, I think. Now this just helps me see additionally where any flattening in the valley might be happening. So as we talked about in this valley, you can see that clearly there's some flattening going on here, but it does look like a forest road or some kind of intervention has been happening here. There's another flat area here, and so on. So you just go through the process and extract all of these types of maps and overlaying them one on top of the other, you to get a clearer idea. And the next thing what I do is I outline I do a flow accumulation map where I can define how a valley is defined based on how much catchment it handles. And this really helps me get an idea of where the primary valleys are and where the secondary valleys or creeks are. Because on some landscapes you may get a lot of runoffs and other waterways, and you're just not sure which one is what. So if we look at this landscape, you can see all of this is water flow that is contributing. But when I define, specify criteria based on which something is defined as a primary or secondary valley, I'm just left with just these few valleys. And another thing I do is usually just a catchment analysis, which helps me define just the catchment for in a particular helping to define a primary land unit. And from this particular catchment analysis, I can extract the clearer boundaries for, say, this just a clear line work for each of these catchments, so they're not just so chaotic. So this is one of the ways to have the computer kind of do a lot of the work for you if you work in a very complex terrain. The other way is to just go to Google Earth or one of the other softwares that I spoke about, and just on top of the topographic survey, you do it by hand. So in this case, we have a property that this is one of the ones Darren has been working on in Australia. The survey is made by Farming IT. It's 10 centimeter contour lines from what he told me. I'll just turn on the 3D terrain for a moment to see if it's easier to understand what is going on here. Okay, it's actually pretty flat. But you can see that these are a ridge line. A main ridge line is moving across the landscape here, and from it are stemming off primary ridges, and then you have primary and secondary valleys. So the process of doing this is you start always with the main ridges. You outline those using a simple path. So clicking here on the path tool, you can change your color and line weight. Keep this window open, otherwise you're not able to draw. It has to remain open. And you manually go and you outline these main ridges. Then off of that, you begin outlining the primary ridges. I'll just change the color for these. Once you outline every primary ridge you have, then you move on and outline the valleys in between. So all the primary valleys. I don't understand, like this one could have been outlined from the very saddle, I believe, but see what Darren says about this. And once you outline all of the valleys, of the primary valleys, you then see where their flow is combined, and you outline the secondary valleys. Just change the style for this. And once all of this is done, you can outline each primary land unit using the polygon tool. So in this case, we will have a one primary land unit going something like this. And another, let's say, over here. Or even this one is more defined. Google Earth is very unintuitive. If you have something like something easier to use, I recommend using that, because otherwise it's very time consuming and something sometimes just unnerving. Just change the color for this. And so on. So you just go through and outline each of these, and you get a complete subdivision of the whole land. Just reading questions. So Darren, should I answer some of these questions now, or would you like to leave them for the end? Because there are just a few of them. You are muted. Okay. Just going through it. Okay, so a question from Ella McHenry. What is a false valley? Well, that's it's an interesting question which I've asked myself a few times, but it's usually an erosion, just a landform that's recently been created by erosion, or like let's say a massive storm event has happened, has contributed to what's one of those false valleys are called runoffs. Sometimes they can get very big, and in fact they can become what's called a true valley, which then becomes part of the primary land unit and becomes like a main deposition area. But most of the time they're just small. Like if you look on this landscape, the hue shade analysis shows you. I mean, they're like this one is most likely just a false valley. Let's see what the I mean, even the software defines this one as a false valley. It's just an erosion pathway. Similarly, some of these, some of these ones, here is a really good example. These ones would be defined as runoffs or other types of erosion pathway happening. By Peter Alemang asks, is a false valley defined then by the amount of catchment? That's how I define it, for at least for my analysis purposes. A false valley is just doesn't handle as much catchment or as much runoff as what a true valley would. So when I'm doing this kind of analysis, you can see these ones that I would define as a false valley are actually contributing to runoff, and they are handling catchment, but it's just not nearly as much as these ones. And obviously, you have to use some kind of discretion when you're doing this analysis. You have to just play with it and come to some conclusion about what criteria you're going to put in that defines what is a valley and what is not. There's a question by Dwara Kanat. A little closed depressions in a landscape could be false valleys. They could just be depressions in the landscape. A valley is just it's not a closed depression. A question by Aujas Planck. Can LAZ file be used for this kind of work in ArcMap? Yes, actually I used your file and there's no problem with it. It works for this kind of analysis and much more even.
Okay, mate.
Okay.
Yeah. So what I'd add to that is that if you, I think someone asked about this being done on very small landscapes. I often use my hand as a landscape because if you close your hand into a fist, you have what Brock Dolman calls the handscape, sorry, and you've got a main ridge across your knuckles with a series of crests, all of which have a different height to each other. You've got saddles in between each knuckle. Each knuckle is the start of a ridge, which is your fingers, and then in between each finger is, or in between each of your fingers is a valley. So if you were to imagine going across a landscape and that was 1 meter by 1 meter, and doing a contour map of that with 1 millimeter contour lines, then you would still see all of the landscape that Georgi has on the screen right now. And so I've done a keyline design of a garden. I did one in the UK years ago. I was working for a client there, and we had some off time, and they said, "Oh, can you do this new garden design for our working farm?" Because they had a demonstration farm. So I did a garden of, I think it was about half an acre or something, and I surveyed it at fairly high resolution, and then from that designed all of the raised beds on a keyline layout, just following the principles that I just talked about, because the resolution of the site was such. Even though it was all on a ridge, within that ridge there were still little primary valleys and there were still little runnels and so on. So I just scaled it down. So one can apply these principles to smaller landscapes once you understand this all broadly. So right down to the smallest scale. All right. Well, we might move over to the other part of the presentation now, if that's okay with you, mate. You're pretty well good. Yep, good to go.
I just changed the presenter to you.
No worries. Thank you. And now I'm going to talk about land capability. So I'll just come on to the presentation. Just bear with me. And land elements. So I hope everyone can see my screen, and I'll come back to a couple of the other questions when we're through this. So the first thing I wanted to talk about, and this follows on from what we were just talking about with Keyline, is that there are all of what we've talked about so far is part of a discipline which is called geomorphometry. I'll write that down so that you can all see it. Geomorphometry. That's a relatively new discipline, and geomorphometry relates to, why has that gone to there? Just bear with me, I'll get this screen back. Geomorphometry relates to the landform. Let's just leave it at that. And they're outside of Keyline and Yeoman's work in the 40s, 50s, and 60s in particular, where he really consolidated all of this understanding. There's been a lot of land management and land surveying professionals who've got together and worked separately in developing all of this discipline. And from the sum of that, we've put that into the Agrarian's Handbook, as you can see here in Figure 2.36. Here are 10 different landscape or land element profiles. They used to be called, well, back when I was doing training in whole farm planning in the early 90s, They were called, a landscape was made up of what was called land components, and that terminology has shifted to be land elements. Now, a landscape, you will find in agricultural landscapes, and I'll just concentrate on that because I should just say that much of our work with agrarians is trying to focus on more agricultural landscapes as opposed to any old landscape that's out there, mountainous landscapes, etc. We're looking at the landscapes where we can likely have agricultural production. And so you see these sorts of landscapes all across the planet as a result within agricultural landscapes. So now you will all be able to define, or should be looking to define, cross sections of your systems using this kind of profile. And most of you will find these landscapes on your either a combination or a single profile here within your systems that you're working with. Why it's helpful is that each one of these systems or profiles and slopes within those profiles are going to have different capabilities. They're going to have different soils, they're going to have different aspects, they're going to have different slopes or slope angles, and so on, different parent materials. And that will all influence how the capability to run different operations or different land uses in these different parts of a landscape profile. And that's important to help us understand. So now, P.A. Yeomans, if you follow a little trajectory here, P.A. Yeomans started off as a mining geographer or geologist, then buys a farm, then starts to really get into soil conservation, which was relatively new in the 1930s and 40s after it started in the US in about 1932, 33. It quickly spread to Australia because of the similarities between Australia, some of the similarities between Australia and the US, especially in relationship to the fact that Australia and the US were both colonised by the British largely, and with obviously a few parts were colonised by the Spanish. But then by the 1930s, all of the continental US is all owned by people of a government system of British descent. And with that came British agriculture and British agriculture was developed in the British climate. And of course, the British climate is very different. It's quite a unique climate, but very, very different to the climates of Australia and the US. Particularly different is the style of rainfall that Britain has, which is much less torrential, much gentler, and much more spread out over the year. Whereas in Australia and the United States, the rainfall is often quite torrential and and therefore quite corrosive or erosive on the landscape. And because the US and Australia both used very similar techniques to those that were developed in a more benign European climate, the feedback in the landscape was quite abrupt, and soil conservation became something that is really important. When you go to parts of the world where the climate is much more benign, and rainfall is much gentler and better distributed, soil conservation is much less pronounced as an activity than what it is in landscapes where the climate has these abrupt and especially landscapes where you have summer rainfall, because summer rainfall is higher in temperature, and often that rain is very torrential and very abrupt, and so it has a really strong effect on the landscape. And if you practice the wrong kind of bare earth agriculture, you're going to get some strong feedback. So soil conservation started in the US, went to Australia very quickly because we had similar issues with similar feedback times from settlement of particularly the eastern parts of, the west of the Mississippi in the US. The feedback time was about the same time as it was in the US, in Australia, because they were settled around the same time, especially after the advent of barbed wire fencing, because that allowed people to control those landscapes with livestock more broadly and quickly. So we have that, and then Yeomans takes that on, then develops an understanding that soil conservation has limitations because it's all about conserving a resource as opposed to using tools and techniques to use fertility as the primary agent of soil conservation. Whereas soil conservation as a science is more about staunching the flow as opposed to using fertility. So I often use soil conservation as an example of where of cause and effect. The cause of the cause of the need for soil conservation is torrential rainfall on landscapes which have been damaged and continue to be damaged by soil exposure and bare earth and cultivation and so people will put in bunds and swales and terraces and grassed valleys and concrete devices and all flumes, all of these different devices in order to slow the flow, but don't actually deal with the primary cause, which is a cultivated, exposed soil surface. Whereas Yeoman's his work on the cause was to look at the inherent problem of a lack of soil fertility, and in doing so, do that across wherever he could take his ploughs, because his plough was his primary tool, as well as rotational grazing. And in doing so, he was able to staunch that flow. He was also able to support those activities by building dams in the landscape or large ponds, which then allowed him to control the amount of water available to those landscapes, thereby increasing their fertility naturally as well. So he did all of that sort of work. Now we bring ourselves forward to today and the work of someone else who was a student of Yeoman's in Alan Savory. Talking to Alan a few times, he said to me that he was quite encouraged by the whole Keyline thing early on, and but saw still that they were working on effects, not causes, and with that developed the whole holistic management program. In particular, the thing that really started to work on a landscape and limiting the exposure of soils was holistic management planned grazing. And talking to a few people on the course the other day, I think I was talking to Roger the other day about this, or Tom, I'm sorry if I can't remember that, about their effect. I think it was Roger up near Manildra there, that his landscape has started to, well, his dams are not filling as well as they used to. And that's not for a lack of the right kind of rain. It's just because his landscape, having practiced holistic management planned grazing for a while, his landscape is absorbing all of the water that falls upon it. And so there's much less runoff. That has an effect on the shape of the landscape as well, because all of the shapes that you see here are an interface between or an outcome of the interface between the geology of that landscape and its chemical makeup, and therefore its proneness to erosion, because soil chemistry has a really big effect on how it reacts to water coming on it and through it. And so that's what we see here. Also, wind has some effect there as well. So that's what we see. So I'd like people to try and go through this week and not only identify their keyline geography as Georgi was looking at, but also to start to look at the different landforms and land elements they have. Now, Yeomans wasn't that concerned about land classes as such, because he saw that every bit of land had some possibility for improvement, and I'd agree with him. The big question, though, is how much how much effort and energy are you going to put in to change that? Now, there's a question on Slack at the moment which I'm just working on, and it was one that Ella asked a while ago, which I just found again, and I'm sorry to have missed that, Ella. And it's about cracking clay soils. Thank you to Per for reminding me. Now, cracking clay soils, or reactive clay soils, or vertisols as they're also known as, or self-mulching soils, they have this propensity to crack really wide open when they're dry and then become quite gluggy and wet and sticky when they're wet. Now, they're very, very tough soil. They have a high cation exchange capacity, but what it actually is, so they have a high volume of clay, and that clay has a high ability to hold and exchange nutrients, so a high cation exchange capacity, or positively charged ion capacity. Now, the actual chemical reason for that reactivity is somewhat of an imbalance between the magnesium to calcium as a proportion of all of those ions or cations that are around each clay particle. So there's more magnesiums than calciums in proportion, and so that chemistry causes the reactivity. Now, you can adjust that, therefore. So if you look at these land classes, well, that land class, it might be, say, mainly grazing class 4 because of these issues around cracking. But we can amend that. Now, I amended a soil once at Geelong Grammar when I was working down there. We got the soil test, and it was a limestone-based soil. In fact, 50 centimetres was a impermeable layer of limestone. It was a limestone base, and the soil had blocks of limestone all through it. But because that soil had been used for cropping for so long, a lot of the available calcium, that is the calcium that's completely soluble and to the point where it's exchangeable in the soil water, was gone. It had been drawn up through all of the crops and exported as bodies of sheep and wool and cereals over 150 years. And we got there 150 years later, and it had huge cracks that you could lose a socket set down. And it was quite dangerous for livestock, especially for sheep, because the cracks in summer were so wide. I mean, a sheep could go down, its feet could go down them. And so the only way you could amend that was chemically, one way. And that required 50 tonnes of lime per hectare on a limestone based on a landscape that had a parent material of limestone. So now you go and charge that out, 50 tonnes of lime. Back then it was about $60 a tonne applied to the landscape. You're talking serious dollars to get that done. We didn't go the full Monty on that. We only did a bit of it just to provide enough to do the crop. The practices that we recommended were to try and elevate the soil carbon levels as much as possible, which is what Yeomans was always trying to do. He was trying to create soil. The sort of the modern way of saying how do you create soil is increasing soil carbon, increasing the amount of permanent pasture or permanent pasture perennial grasses, thereby increasing the amount of liquid carbon transfer via photosynthesis and exudates into the soil, such that it's carbon that actually increases the amount of water holding capacity of that soil and structure so that it becomes a better soil. So long answer to that is that what we're trying to do, and this is the Keyline attitude, is not look at this land classing system as being the be all and end all, because you can actually change the class, but it will require different amounts of investment. So obviously, if you go down to class 8, where it's unsuitable for agriculture, you are going to have, in order to make that suitable for agriculture, you're going to have to make much greater investments, and people have. With swamped landscapes around the world, swamps usually have lots of residual fertility because fertility has gone there, and they've been wetlands, which are great accumulators of biomass. People have drained swamps and then performed really valuable agriculture on there, but it's taken a lot of effort and investment, often government-based investment, so investment of a government scale in order to make that suitable for agriculture, and so on. So it is quite helpful, I think, as a starting point to apply land classes to your landscape, but don't be stuck in thinking that those classes will always remain. But do understand that each class, if you want to have it get more capable, then you're going to have the higher the number of class, the more you're going to have to spend in making it more capable. Okay, so we've done enough there, and you can read through that. This is all in the Agrarian's Handbook, obviously. Now, the other thing, this is from the New South Wales. New South Wales and Victoria, in Australia at least, as states, they've probably done the most work as far as having us understand land capability, because the soil conservation authorities in both of those states have been pretty strong and done a lot of work over a very long period. And so this is some of the more recent work that's been done to have people understand what factors limit capability, and then have us understand what are some of the things that you may or may not be able to do. And so that's what we typically look at there. And again, I won't go through all of this. You can do that yourselves. Now, what am I doing here? Why is that? That's because I've got to the end of that. Now, I just wanted to look at a couple of other resources that we have out there. One of which, I'll just get to it. Here. In the Agrarian's workbook, which you have a copy of, and yes, I'll make that bigger, because none of you will be able to see any of this. Just bear with me. Oops. Wrong button. View. Oh, yeah, just double it. I'd expect that that'll be bigger now. Now, this is in the workbook, which I don't know that I've shared with the drive yet, but it is in the, if you go to Agrarian's Platform Resources 9 Economy, the Agrarian's workbook. I have referred to it before, I think. So in any case, what I have here is a sample of an environmental management plan that was done as part of a planning permit or a development application for a particular client years ago. This is just a template, which I've done in Excel because it just makes it relatively easy to replicate and keep in check. Now, I have in here a list of what the developer proposed to do: boundary realignment, intensive agroforestry, riparian protection and revegetation, all these nice little keywords that municipalities tend to like. And then I've got intensive forestry, farm stay, bed and breakfast, intensive garden agriculture, right? And just looking at what's been intended. Then I've got the requirements of the respective planning scheme. And then I've got what the planning scheme clauses are that are important. And look, it doesn't matter pretty well everywhere you are in the world. It's generally the same kind of requirements that are had here, which is why I'm going through this. And then you come down to the land capability classes that we've done. Now, generally, when we're looking at land capability across the world, the interest that municipalities have or government have are the effects of agriculture, the effects of effluent disposal, building farm dams or ponds or whatever you like, roads, so internal roads on that property, what's the capability of those? Building foundations, right? So those five are the sort of big four classes that, or things that municipalities are typically going to have in their array of consideration before they give you the stamp, right? Now, so they want to know what kind of agriculture you're doing and how suitable the site is for that, or parts of the site is to that. How suitable your place is for effluent disposal, depending on what your operation is here. Now, I know Michelle McManus and Jeff Power on this call, and when they built their poultry processing plant on their site, and I think Dan Cordner, you're doing the same. You'll probably have to go through the same thing if you haven't already. You'll have to go through some sort of land capability assessment to determine, all right, how are we going to dispose of the effluent that comes from that very high grade effluent that comes from poultry processing. How's that going to happen? Is your landscape actually capable of doing that? Because if you live in a swamp or you're close to bodies of water which are being used for human consumption and so on, then the bar is going to be set very high for you, or it's going to be really difficult for you because of the soil types for you to dispose of that water. It's going to have to go through a very high grade of treatment before you can get to that. If you look at roads, well, let's say your property is completely covered in rocks. Well, then it becomes, or you've got a depth to rock which is really shallow. Then the capability of that landscape, or it's really steep, the capability for building roads in that landscape is going to be high. Similarly, if you're trying to build foundations for buildings and you've only got a foot to 2 feet to rock, well then building foundations are going to be difficult, and so on. So there's all of these different considerations that we have there that you're going to need to be considering yourself. Now, what I've done with this particular setup is I've looked at the different geologies. It's just the way that we do this in Victoria. So I'll look at the different map units. So I've broken up this property into, or this project into its different land elements, and apply, because the geology of this site is all the same. I've then applied the different elements, and then using some of the guidelines that are out there. So we have guidelines in our state which I've shared with you, and as you can see here, are referencing Food and Agriculture Organization of the UN, USDA Soil Conservation Service, which is now called the Natural Resource Conservation Service, which is the NRCS, which we've referred to a few times, and so on. That we use this as our primary tool for helping us to to create the guidelines for determining what class we're actually giving. Now, I've put some of these references. If you go to our 10-week, in week 5, I've uploaded some of these guidelines. Now, they're for our state, but they are using internationally accepted parameters. If you're in the US, I'll see what I can find for you there, but definitely there are parameters that have been established there, and there will be others in other jurisdictions as well. But these are quite simple. I'm familiar with them, and they'll be helpful to you. All right. So I'll go back to here. Oh, no, not there, sorry. So what else we have in here is, no, that's all just the reporty stuff. So anyway, so that's primarily what I'm looking at there in terms of land capability. I might head over to questions now. So just bear with me as I get this screen right. And where is it? Pardon me. I've lost my screen for, where are you? Oh, there you are, my control panel. All right, so we've got some questions over here. All right, well, let's fire away. We've only got a few there, so we've got 38 minutes or so to go. So any questions that we've got to ask, let's go for it. Okay, there's one question here from Morad. Thank you, Morad. Around about this question is, what are some of the practical implications of having a short landscape versus a long or a medium or a long one? Yeah, now Yeoman's looked at this, and I might just look at some sites here. Let's go to Google Earth. Just bear with me. Let's have a look at clients. I'll go to Muckleford first, and we'll have a look at that because we were already looking at that today. Now, these landscapes are defined. Yeomans gave this definition of a short, medium, and long landscape. So, a short landscape. I'll just be official here because I don't have it in my memory. So, just bear with me here. Open. Pretty sure I've got it here. I hope this doesn't crash like it often does for me. I don't think I do. But from memory, a short landscape is up to 300. It's 300 metres, I think, or 500 metres from the main ridge to the secondary valley or creek or river or whatever it is going to be in drainage form. So if you look at this one here, we've got, just change that to metres. We've got from here to here, yes, a bit over, nearly 300 metres. So everywhere we look throughout this, and this is one of the, I'll discuss this plan a bit further, but this plan here, or this particular property, or even though it's about 600 acres, is composed of relatively short landscapes. Now, I think Aljaz, I might just look at one of your files that you put up the other day. Because you put up a few maps the other day. I'm going to guess that that's probably not as easy as I thought it would be. I'm going to guess, shall we? No, that's not going to work. All right, I won't do that. But the landscape that you had, which was quite mountainous, I think that that being the case, it's probably that you've got quite a long landscape, and a long landscape is more than a mile, so more than 1.6 kilometres. So this distance from, say, here to here would not be 300 metres, it'd be 1,500 metres or 1,600 metres. Now, the importance of that from PA Yeoman's perspective, and this is where I'll go to the Keyline sites. Let's go there. Let's have a look at, say, Yobani. So there's Yobani, and I'll just take this back a bit in time. Thanks, Eljaz. I'll get back to that in a minute. Let's have a look at cadastral topo. Back or not? Yeah. So this landscape here, let's just measure this out a bit. I'll get that in a bit. So you can see here there's this dam, this, if I just go there, this dam, and this dam, this point here, right there, that point there, that point there, are all what's called key points of the valley. This one over here, he's met the two key points of these. Sorry, he's come further down from the key points of these two primary valleys and put this effectively as a secondary valley. This one here, I think from memory, is also a key point there. So he's got those. Now, in terms of this road here, Grossvale Road, is following the main ridge of this landscape. And if you go from here down to here, it's what you'd call a short landscape. If you go from this main ridge, however, down to here, it's a medium length landscape. Now, if I took you to another landscape, so we'll just go to another one here. All right, Carisbrook Station in Winton in Queensland, which is 50,000 acres. Now, Carisbrook, its main ridge is right up here. You can, if you looked at this landscape here in profile, from, actually, I'll just draw this on. So if you look at some of this from the ridge, I'll just draw this profile so you can see it. Get that pencil a bit smaller. So if you were to go from here, actually I'll do from here down, right down to the river, which is down below here, then what that actually looks like, this whole line along here, that goes along here, is actually what they colloquially call in this part of the world a jump up. So what it looks like is from A through to B, is it goes along like this, long, gentle, and then it jumps up like that. So this is an ironstone plateau. And for Charlie, this is really valuable because this is naturally ironstone. So it's got a small soil covering over ironstone. And so this is like a big roof. And Yeoman's identified this when he did his consultancy here in 1966 and found that, all right, well, we can collect the water from that and then use that to build these quite large dams. Now, the landscape length here, let's get back to here, is from this point here, the top, down to there is 12 kilometres, right, or more. So it's a very long landscape. Now, what that means in keyline terms is that you can zigzag, if you like, a lot more water across this. Oh, wrong one. Go away. You can have water because there's the contours of the landscape are sort of going through like this. You can harvest water here, have it run out here, right? Harvest water again, run it out, so on. So it just means that you can have a lot more activity from a keyline perspective over that slope. Whereas if it's a short landscape, then you only have so much capability because your landscape is very short from the top to bottom. All right, so that's what that primarily means. All right, now. All right, so the next question of this is from Jeff and Michelle. Where do I find the colour palette you would like us to use for drawing the ridges and valleys? Georgie spoke of this. Georgi, do you want to mention that, mate? I'll just unmute you.
Yeah, I just replied to that and said that you can use any color palette you like as long as it's clear, like a pure color, like yellow, red, blue, cyan, and so on.
Okay, cool. Thanks, mate.
No problem.
All right, now, Jesse Dawkins, why would keylines not extend right out to the top of the primary ridges from the key point? That's a great question, and we can go back to the presentation for that because of the nice graphics that Georgi has been able to provide us. Let's have a look at this one. Present. Hopefully, pointer. So, actually, we'll go. Can we go? Yeah, that one's better. Now, if you were to look at, there's some very interesting things about this that Yeomans was able to look at. Now, and I have quite a few diagrams in the Agrarian's Handbook in the Geography chapter that I hope help with this as well. Now, one of the things I'd like to do here is, that won't draw. Hang on, pardon me. I've got a pointer. No, okay, I'll see if I can get a drawing tool here. Okay, that won't work. Okay. Why can't I draw on this? Bugger. All right, just bear with me for 2 shakes and I'll get... I can do it in here. Let's do that way. View. Okay, that's better. And view. Okay, hopefully that's big enough. Now, if we've got this key line here, there's a few pattern things that go on here. This is from a pure key line perspective in terms of key line pattern cultivation. If I was to extend this out to the ridge, and then I was to, because one of the and I'll do that, I'll go right out to the ridge here. If I was to run parallel with that, let's just try and do this here as a cultivation pattern, because that's one of the primary uses for understanding where the key line is as compared to the other use, which is the identification of positions of dams. What you'll just mucked up that last bit, but I'll just fix that up because it does affect the explanation. Let's just have a look at the shape of these lines in reference to the landscape below, right? Now, it's pretty clear that this first line that we have is parallel to the contour, right? We use the contour to define that position, right? So that one's on contour. So from the perspective of water's sort of staying put, right? Now, for the other lines that are here, I don't have enough detail underneath here completely, but we'll just maybe just continue a bit if we can. What's particularly interesting to me is that when we've come out onto the ridge here, so one of the primary objectives of Keyline is to try and move the water that naturally always gravitates towards a valley, right? Because water is moving at 90 degrees to a contour towards the valley, right? And when you look at this landscape, the ridge, if you like, the ridge is here and here, this particular primary ridge, whereas the valley is here and here, right? So of the landscapes, the ridge is much bigger, has better solar exposure, generally has better drainage in the soils and so on. So it's the capability of a ridge from a land capability perspective and a production perspective is often higher than it is of a valley because the valley is often shaded or shadowed deep in shade. It has heavier soils which may well hold on to water too much. So you have drainage issues and so on. So it doesn't get as much solar access, etc. So there's limitations often with valleys. And if the question I suppose for ridges is if only they had enough water, then they'd be so much more productive. And so that was what the whole premise of Yeoman's pattern cultivation program was, that if we can, well, A, potentially build dams on these key points and then have irrigation which comes out from those dams, well, then that can help us to irrigate these ridges and bring them into greater production, number one. But number two is that if he had a cultivation pattern that moved water from the valley out towards the ridge, well, then just natural rainfall would be held on the ridge better as well. But because I extended that so-called keyline out to the ridge, let's look at the relationship between. So this is the 160 contour here, right? And look at this line here. What's it doing? It's actually going towards the ridge, towards the valley. So it's actually falling towards the valley. Now it's giving more water. Same with this one. You can see it's higher here than it is here. And so therefore, the water, because we've followed outside of the curve of the ridge, it typically goes that if you run parallel outside of the curve of the ridge, then the water will fall away from the ridge in whatever those lines are, cultivation lines in particular, and go back to the valley, right? So doing what you've just suggested, Jesse, is actually is a ridge dehydration strategy, okay? If you have a look at the Regrarian's Handbook and the work that I did there, using Yeoman's own drawings, let's get rid of this thing. You can see here. I spent a bit of effort making. Let's get rid of this drawing over the top here. Yeah. Oops, wrong one. That this is a really good example so I took one of Yeoman's old drawings, blended it together, and then made these diagrams in which I'm able to explain the difference between following a keyline or creating a keyline guideline and following contours and using a grid, and then looking at doing a comparison with an algorithm a logarithm to determine the relative importance of each of these attributes. So when you have a key line, a true key line in the valley, and then you extend it out onto the ridge, and you run parallel with that, you will always have ridge dehydration. So one of the principles, if I could make it really simple for you, is that, and this diagram illustrates it beautifully, is that as you go inside of the curve of a contour, as you go up or down the slope. So in a valley, if you go inside of the curve of the contour, as you go down the valley, the landscape gets progressively flatter, right? So therefore the contours get progressively wider apart. As you go, so if I was to all get you to look at your fingertip, put your pointer out, and look at your fingertip as being one of those the bottom of a ridge, and your fingernail is effectively the lowest contour on that of that ridge, and then if you were to draw a line or mark that contour and then create a curve inside of it, which is what I'll do right now. So if I was to, I'll make this red. If I was to do a curve inside of this contour, then what will happen to the curve? As you go inside of a curve, it gets tighter and tighter, whilst the underlying contours as you go up a ridge get flatter and flatter in shape. And so conversely, if you're water and you're landing on this landscape with this as a cultivation pattern or a tree pattern or a vineyard pattern or whatever it is, then water is going to move towards the centre line of the ridge. And so that's why we don't run the key lines out onto the ridge. If I did that, view colours in this particular diagram, so if I ran this key line and continued it along here, right? Well, the two aren't going to match up. So I've got one key line that's going to run out to here, and then I've got another one here. So let's just follow that through. So there's your two false key lines, which some people do this, believe me. So now if I run parallel inside of that, that works out okay. Right, so here I am, I'm on my tractor, I'm driving along like so, and I go along. I've run parallel with the key line, which is okay, because I should make the point that one of the revelations of Yeoman's key line was that it is the only landscape that you can run parallel with, both above and below, and I'll show you this in a moment. So here we are, we've come along in our tractor. What do we do now? Well, we probably, seeing we've marked all of this out, we'll keep running along here, and then we'll get up along here and then run along here. So this is all good, right? And then we come along and that works out to be all right there. Then we join up. Yep, that's all hunky-dory. Good in here because we're in the keyline zone, so that's all fine. Then we come along here, and you can already see that the mischief is starting to occur, right? So this point here, right here, is lower than this point here. So already, just after a couple of passes, we've already got dehydration going on, right? And that will continue as we go with each pass. So that's why Yeoman said what you need to do is find the lowest contour on a ridge and then have that match up, which is what we've put in this diagram, have that match up with the shape of the keyline, which is what we've done here. And then you create this guideline, which is a reflection of the shape of the keylines. Have that go down until they meet the lowest contour on the ridge. And then when you've done that, as we've got in this diagram, then you run parallel above and below that, and you'll always have water moving towards the center of the ridge, as you can see with each and every one of these lines. Right, so that's it. That's the primary answer to your question there. Jesse, thank you. All right, now I'll get to the other questions. Oh, thank you. I might get back to that later, or we can do that again. Can you guys re-explain how to set up the primary land units again, as well as a definition of what a secondary valley was again? I think maybe look back over the program, and so that will help. Look back over the webinar, but in simple terms. I'll just go up to here because I've got some maps that we've already got drawn. So here, and this is a real map. This, all of the maps that Yeomans had weren't real maps; they were imaginary maps. So what I did in the Gregorian's Handbook, and Georgi has done the same, is taken real maps and looked at them because there are some difficulties with applying some of these patterns, which need to be not sugar-coated. So here we have a main ridge, right? Now, again, probably I'd ask you, Taylor, to get your hand out in front of you. Now, if you were to draw a line right along the center of your knuckles, right? Because if you put your knuckles up in front of your face and have them so they're right in front of you, and then you can see that there's like a divide line. Right, if you go right over the top of your knuckles, you can see that if I was to pour water on there, right on top of the knuckles, water's going to go one way and the other way. It's going to go back down your arm, or it's going to go down your fingers, right? So Yeomans called that line that's on a ridge, that the apex of a ridge or of a main ridge or a primary ridge, he called that the water divide line, right? Because water is either going one side or the other as it falls. So in this case, water is either going this way or it's going this way, right? And conversely, out on a ridge, it's going this way and it's going this way if rain falls on it. Right? Now, if you were again get your hand and you've drawn that line along your ridge, along your main ridge, and now you draw the line right down to your fingertip, right along the center of your finger, right? And then put your hand, your other hand, so it touches, your finger touches the bottom of those other fingers, right? You got two fingers joining one finger, right? Well, that line that is enclosing that valley. So you've got one finger here, right? And then you've got another finger with your mangled hand here, and another finger here, right, of your mangled hand, right? So then you've drawn a line along the, I'll do that in green. You've drawn a line between the knuckles. So there's one knuckle there and another knuckle there, the two crests, and then you've drawn another line along the center to here, and then another one down along here, right? Now, if you get rainfall, then where's water going? Well, water is going to go, as I said, 90 degrees to the contour. So if it's falling within this boundary here that we've just drawn, right, then it's all coming into, use the pen, not the mouse, it's all coming into here, right? And so that becomes what we call a primary land unit, right? Or what I also will call the first catchment, because it is effectively the first catchment. And every landscape in the world is made up of these, right? And so the amount of water, so if I look at the next one, here's the next one right here, right? Because we've got a primary valley, well, we've got two primary valleys because we've got two key points coming into, so the two primary valleys join in this particular landscape, and then that becomes a secondary valley there. So that's a second, that's a primary, right? So when two primary valleys join, then they become, sometimes the two primary valleys will go straight into the ocean, right? So you go from the third order of catchment to the seventh order of catchment. Sometimes it'll go from primary to secondary to creek to river to estuary to ocean, right? So you'll have the full 7 orders. Sometimes it's very short, right? So it just depends on where you are in the world. But you will always find these primary land units, and there'll be each one of them because of their different surface area, right? So this one might be 20 units, this one might be 15. Each of them will have a different amount of water that comes off them, right? So they'll have a different yield. Think of the landscape just like a roof. If you look at a roof, especially a roof that's made of corrugated iron, right? It's got you've got your ridge cap, you've got all of these corrugations, which are effectively ridges and valleys, and right. So you've got that roof. Now let's say you've got a roof that looks like this, right? So it's a short roof on this side and a long roof on that side, right? Well, that roof on that side has a relatively small catchment, and it's got a gutter, right, and a downpipe, and if you're doing things right, that should go to a tank, right? So it's just exactly what we're doing here. So there's your ridge cap. Now that's what we would call a main ridge. Then we've got, let's say you've got that more open panels of like a lot of people in the US have this. They've got a ridge, a roof profile with little hidden little joints like this, right? So in this case, the valley. So this would be your primary land unit. Each one of these between your small ridges would be a primary land unit, right? Or a primary roof unit. Each one of those will have their own individual catchment. If you were in a corrugated roof, which is like a landscape, well, there's the centre line of the ridge, of each ridge. Each one of those is so that's a primary land unit, primary unit, right? That's how it works. Okay. Done enough there. Next question. Oops. Okay, can you, this one's from Dan Cordner, can you do a keyline analysis for our largely flat landscape? Only a few metres of fall across 60 hectares. Great question, Dan. What I would say is that yes, you can, but you need really good topographic information, and I think you're onto that. Can you just maybe supplementary answer me what contour map, what sort of contour map intervals you're looking at getting, or you can get, because like for example the one that we looked at before with Muskerry. This Muskerry farm that we were looking at before. This one has 10 centimetre contours. And the reason for that is because, so those red lines are 50 centimetre contour. This is I wouldn't say it's a flat landscape, but it is very gently undulating. And so we got that level of data so that we could just get the kind of resolution that helps us to define this landscape a lot better. Now, your place is going to be even more so. It might be that your landscape, you might need 5 centimetre contours. You will still find, even on a 5 centimetre landscape, and you'll know this already, that there are dry spots and there are relatively high spots and relatively low spots. The value of that is that once you are able to define that, just as we have here, so if I look at this landscape, the first thing I did with this landscape I'll just get rid of these layers. The first thing I did with this landscape was I drew the main ridges, the primary ridges, right? So I always do that with every design. And the reason for that is, as Georgi was able to point out, is that it makes design simple because a lot of the landscape is basically telling you where to put things. By creating what I call the skeleton of the landscape, all of these ridge lines. Now, you will find those same lines even on that very flat landscape that you have. That will help you to position where you might put roads and how you might subdivide this landscape such that you subdivide it into its primary land units. And this is the elegance of this. Now, of course, we did this on this particular property. The only good fence on this property is actually the boundary fence. All of the internal fences have been neglected from years and years of share farming, where the share farmers have put absolutely no effort or energy. In fact, they've done a lot more cropping on this property. And as soon as you get people doing cereal production, well, then the fences are superfluous. So the client here was saying, all right, well, we need a completely new fencing layout, and I want to turn this into a perennial grazing system, and if we're going to do cropping, it's going to be pasture cropping, not cultivated cropping. So we went through this process, and once we defined the geography, then we looked at what the catchment, because we needed to sort out how much water we had. So this area here was determined because we looked at where are the highest points in the landscape to store water in dams. We had a dam here already and a dam here, and they were the two of the highest dams in the site. So we worked out how many hectares of catchment there was. So there's 21 hectares of catchment. I've got this actually blow by blow. I've got this in I don't think I have it here, but anyway, I'll send you the link. It's on our website. So we've done that. Then we've positioned the dams and the catchments for those dams, right? So we've dealt with the water layer now, so that's taken care of. And then the next layer was the access layer. So as you can see here, the access layer basically follows the main ridges and then a couple of the primary ridges. I'll just get rid of that catchment data. And right, so didn't have to even think about, this is the elegance of it again, that we're trying to create somewhat of a circuit, which is important, but we're also trying to be on dry ground where we have the best view, because one of the biggest things in grazing systems or in any agricultural system is observation. So we can drive from the house here, and as we drive along this road, all the way along here, which in this case is not a road at all, it's just two fences with on either side with a ridge, and you just drive along. In the case of here, it is a made road because we're using it to harvest water for this dam, and then it overflows to this one, and then it goes to here. But by and large, these aren't roads, they're just access ways. But when we drive up on top of a ridge, you can see both sides, whereas when you drive down anywhere, you can't see both sides, so you lose a lot of your power of observation. So when we drive across this place, we're high and dry, which means that we're dry, so we're driving on a landscape that's naturally convex already, and so it has a high capability as a road landscape because it already is effectively a made road, and we've got super high grade visibility. The other thing that we did in this landscape was that also became the position for the water pipe. So we pump water from this dam and this dam up to a 500,000 litre sized tank up here, which is enough water for a month of cattle grazing. And that's the highest point on the property. So we use that as a battery of water. And then we've got a 2-inch pipe grid, which I'll just get rid of the access and you can see. So you can see that dashed black and green line there. That's a 2-inch pipe which goes also along that ridge, and it's all falling because everything is falling, right? Remember, Georgie talked about the descending nature of these landscapes. And so that point being the highest, we have, as soon as we get water up to there, we've got gravity of flow all the way along, right? And so we're like you could go and do a square grid if you wanted to. Absolutely, go for it if you like, and that might work for you on a landscape like yours, Dan, because it may be just that flat, and you've already got a lot of looking at your landscape as well. You've already got a lot of activities going on there already, so there might be you often have to work in with what you've got. So. But you may not. And so you can choose where things might go. So in some cases, a pure grid might be the most effective thing for you. On other cases, if you've got new fencing or relatively new fencing and an existing layout of roads and infrastructure, a more of a grid, a square grid might be a better opportunity for you. But I'd encourage you to look at, if you do have a bit more of a blank palette, then start to look at this type of orientation for things, because then when we get to fencing, these primary land units effectively become the fenced paddocks, right? So we've already got this fence around the perimeter, so now we've got all of these areas. Now I've got a fence down the middle here, down the secondary valley. I've got it to there. Now, the reason why I've got that there is because this is a grazing property that has that will have up to about 500 head on it, which is not a huge number, but about that. And one of the rules that we follow is that the electric fencing reel, which is used to fence off livestock in daily or multi-day moves, it usually holds a maximum of 400 metres of wire. And so I saw that distance from there to there was 400 metres, and so that worked. And if we're doing grazing, so we've got a water supply, I'll just draw some of this on. If we've got a water supply which is at the top of the hill, right, up where it's high and dry, and we just, for our grazing strips, we just put a fence down from here to here and move the trough anywhere along here. So the trough can be anywhere because we've got a movable trough system. So we can graze up and down. We only have to set up one fence every day or every time we move, and it goes up and down the slope, which means that we're bringing the nutrients from down below up here all the time. And the water, if it happens to spring a leak or whatever, which they sometimes do, sometimes on purpose, it's running back down the slope, right? So there's a few reasons why this all sort of starts to work out nicely. All right, so yes, Dan, we'll look at that more as we get along. Next question, and we're just at time, and we've got a lot of questions as I expected today. This one's from Will Davis. How well could you use a 20-foot contour map of 1,200 acres in defining primary land units? Yeah, as per the answer here, it comes down to the to the degree of slope across the property, indeed. Let's have a look and see, Will, what kind of map you can actually get there. You may well, I know that there's a national elevation database that's been developed in the US. So let's see if we can do a bit better on the mapping side of things. But if it's a 20-foot contour map, that's, what's that? 20 feet is about 5 meters. Then that should be fine. I'll give you an example. I'll just go to our website for a minute. Use that. The example that we use for our land planning process, which a few of you might have looked at. Whoops, wrong one. Land planning process. This particular site. This is about, what size is this? This is a 570 acre, so 230 hectare site, so a bit smaller than what you've got. So we've put the cadastral layer. This is a 5 metre contour map. So you can see here that what we've got is about a 20-foot contour map. Now your property would be another 4 of these or so. Then what we've done is, in this case, I've found the highest points in the landscape. I've looked at the water harvesting drains, calculated the catchment, drawn out the irrigation reticulation system, or the stock water irrigation, again a grid of 2-inch pipe that goes all the way around, and it follows all of the ridges. So we've got a main ridge, a very clear main ridge that runs along here, and then there's a series of primary ridges which come off that, and we've marked those, and that's where we've put our pipeline, again in a circuit to equalise pressure as well, because it's closed, because it's a gravity system. So in this case, we've got these 2 dams which are plumbed to put water up to this highest point on the property, which is here, and in this case, it was a 62,000 gallon or 250,000 litre tank. Then those roads have gone on there. We've then got, in this case, they wanted to put a savanna, so we designed all of the keyline layout for that, positioned all of the trees, and there we go. So, yes, you can. Obviously, the better the contours you can get, the better it'll be. And similar question to with Ella, with a contour map we have, it's at 5 meters, which is, you're just up the road from this property I showed. It's difficult for us to define our primary ridges. We've walked around the paddock more than a few times and we're still not sure where it goes. Obviously, a higher resolution is one way to work this out, but I'm wondering whether it's worth the effort of hand surveying or cost of getting someone to make a map, given that the area we're talking about is smallish. The paddock in question is about 2.5 hectares. Yeah, I think, well, your property is bigger than 2.5 hectares. Let's see with the data that's available, because we've just accessed this Elvis data and we're seeing what it looks like across Australia. Some of those areas, it looks like it's okay. Okay. Right. Well, we're over time now, so we've got quite a few questions. I think we might carry these over into the week. I think it probably wouldn't hurt for me to. I think this week would be a good week for us to have a supplementary session where we do where we have another recorded session. I'm happy to do that maybe in 3 days' time. Just so that we can bank some of these questions, which are always going to be coming. I knew that this would be a heavy question session because a lot of people are interested in Keyline and they really want to understand it. And how about we do this? How about we do the best that we can to get our maps in order? So questions such as you've got here, Justin, I'm having a difficult time with my property differentiating where the boundary is between the primary ridges and the primary valley out. My contour lines seem to stay the same distance apart until they get off the ridges. So let's have a look at some of those maps. Let's do what we can for a few days to follow through the exercise, which is just so I'll get to that. I had this all prepared. All these birthday messages of people I don't know. How does that happen? Where are we? So the Rex.farm, to go through all this baloney again by the look of it. Whoops. My courses. And what I want you to be able to do this week is to complete a Keyline geography map. So what we want you to do is to basically do what I did on this property here. I'll just turn off these other layers. And that is to mark the ridges. Don't get too hung up. Like if it's bothering you about main ridges and primary valleys and secondary valleys, if that's a bother to you at this stage, don't let it be, right? Just mark valleys and ridges. If you can just do that, that will say to me that when we look at it, that you can read a map okay, because for some people that's going to be a struggle as well, just reading a map. It's a new language for a lot of you. So do what you can to just mark the ridges and valleys. If you want to go a bit deeper and start to differentiate between what a main ridge is, which I call kind of the roof of the landscape. Think of a roof again, like I described. If you want to differentiate further and do main ridges and primary valleys and secondary valleys and so on, if you want to do all of that, go for it. But the main thing that's important to me is to define the ridges and the valleys. Do that. Let's have a look at where you go with that, and then let's look at having a supplementary session this week so that we can really make sure that we're as far along as possible with this, because I'd really love to make sure that, because I'd really love it that if we can get over this piece, because as so many of you will be able to see right now, that if you get this right, then it really lays the terrain for so many other things that you do. And that's like I said, it's one of the really elegant things that we have in using Keyline geography as a way of explaining all of this, explaining where things go, because that's so much of a question, as Georgi pointed out before, right? There's a lot of difficulty in doing a lot of stuff. Let's not make it any more difficult than it needs to be. And as P.A. Yeoman said in that piece, water is the principal planning medium. Water comes before roads and fences and everything. If you get the water right, you get the roads right, and you plant the trees in the right place, and no one does that. And that's true. There's no other framework that I've come across that elegantly has the landscape determine where things go. And that's quite liberating, believe me. All right, well, we've got a bundle of questions to go there. I'll gather all of those before I close the session. And bid you all a good day, and look forward to what will probably be a mountain of very technical questions this week. And we've got a bit of a backload there. I think I've done pretty well in keeping up, but we'll look forward to having even more answered as we go along. All right. Well, thank you very much, and enjoy your day. And and thank you very much also, I should say, to Chris Moore, Daniel, David, and Theron was there for a while as well, and my friend Georgi. Good time for you to go to bed now, mate, and all of the other people in Europe. So thanks very much for being on today, mate.
Thank you.
All right, sleep well.
You too. Have a nice day.
Yeah, thank you. All right, thanks everyone. talk to you